Hello everyone, my name is Ashton Mickey and today we're going to be talking about cross-tenant service communication in Microsoft Azure. To give you a quick rundown of the agenda, first we'll cover some basic context you'll need for the rest of the talk. Then we'll talk about the problem you'll see when you want to have services in Azure communicate across tenant boundaries. Then we're going to have a look at a couple solutions to the problem, and I'll talk through some guidance and considerations that you're going to want to keep in mind. Now, obviously, we're here today to talk about cross-tenant service requests. But first, I want to take a moment to provide some context, a quick refresher on some fundamental concepts, as well as describe how communication to a service works in a single tenant. And I'd say, hang with me, even if you already know this stuff, because this is just going to be a great primer before we move into the cross-tenant case. And I want to start today by assuming that we have a web API that we want to protect. And specifically, let's say that we want to enforce a policy on our web API where we allow certain callers to use our service and we deny everyone else. And there's a core requirement in this scenario, which is when people and things are calling our service, we need an identity context to inform our response. When our service processes a request, it's important for it to know who sent that request. And so if I could ask you for a moment to forget everything you know about identity and consider this problem of establishing an identity context per request, and think about how you would go about doing that. Some questions you may start to ask are, well, where would this identity information come from? Would the client provide it in their request? And if so, could they just make up whatever they want? And even if they send us info that looks good, would there be any way to verify their identity assertions? And the question I'm driving towards here is, could we create a means of authenticating our clients? Now, the answer is, of course, yes, but that would be a lot of work to take on ourselves. If we're really starting from scratch, that's going to require some new infrastructure, a working familiarity with cryptography, or at least how to use it. And so it's complicated. And it's a lot easier if you're able to delegate your identity problems to a trusted identity provider. And Azure Active Directory is the cloud-native identity provider made by Microsoft. Now, Azure AD is a huge product. It's got a ton of features, but it of course includes core functionality you'd expect out of a modern identity provider, like the ability to register user accounts, application identities, and protected APIs. It's also going to host its services in a highly available fashion. So in general, we can count on those services, like its token issuing service, being there for us. And so if we return to our example where we have this web API we'd like to protect, and we've decided that we want to use Azure AD to help protect it, we need to do two things. Number one, we need to register our service as a protected API in Azure AD. This way, Azure AD knows who our service is, and then clients will be able to start requesting tokens from Azure AD, which they can then use to make authenticated calls to our service. And after we've registered our API in Azure AD, the next step is to update our service code to integrate with Azure AD. And thankfully, the Microsoft Identity Platform provides helper libraries and a multitude of programming languages that are going to help with this. But essentially, these are libraries that will help us process and verify the tokens that we receive. I want to quickly note here that when we register applications and we register APIs in Azure AD, we're doing so in the context of our organization's tenant, which is our own dedicated instance of Azure AD that has unique registries of identities and entities that are specific to our organization. So let's have a look at a simple illustration of how two services can communicate in the context of a single Azure AD tenant. And by the way, you'll notice I've drawn a box around everything here and labeled it tenant A. And one thing I'm communicating in doing this is that the services inside it, like web app A and blob storage A, they have identities within this tenant. And in fact, it's a requirement that before this flow that we're going to walk through can take place, the identity provider needs to know all the parties involved. So in this scenario, we have web app A, and it wants to call blob storage A. So in step number one here, web app A is going to call the Azure AD token service, and it's going to say, hey, I'm web app A, and here's some proof, like a secret or a signed client assertion. Here's some proof that I am who I say I am. Please give me an access token for blob storage A. And so at step number 2, the token issuing service is going to validate the caller's proof of identity. It's going to authenticate that client. And it's going to respond, hey, I know you, web app A. Oh, and you want to talk to blob storage A? I know that guy too. Sure, here's your access token. And after that exchange, web app A is going to have a proper access token, and it's going to be able to make authenticated calls to blob storage A. So to wrap up this slide, I'll point out quickly that this illustration doesn't say anything about authorization. By receiving that token, the storage account will be able to tell who is calling it, and that's great. But I don't mean to imply that the web app can do whatever it wants in the storage account. Maybe it's trying to write some data when really it only has read permissions. So the web app's requests are authenticated, but they're not necessarily authorized. And we'll touch on authorization a bit later. Now, to pivot back to the topic of today's talk, now that we've reminded ourselves of the basics, let's talk about the multi-tenant case where we have a service in one Azure AD tenant which needs to communicate with a service in another tenant. For example, let's say service A in tenant A needs to talk to service B in tenant B. Well, as I mentioned before, each Azure AD tenant is a completely independent identity provider. This means that tenant B has no idea about the identities which exist in tenant A. Therefore, service A cannot authenticate to tenant B, and therefore can't talk to service B. If we modify our previous illustration to account for the cross-tenant nature of the problem, the flow is going to go something like this. Step number 1 is going to be almost the same as last time, with the exception that the web app is now calling the token issuing service in a separate tenant. It's not calling its own token issuer. Web app A is going to call the token issuing service in tenant B and say, hey, I'm web app A. Here's some proof that I am who I say I am. Please give me an access token for blob storage B. And in step number 2, that token service is going to respond, I'm sorry, who are you? I have no idea who you are, so I'm definitely not giving you any tokens. And at this point, web app A is out of luck because blob storage B is protected by Azure Active Directory, and specifically the instance of Azure AD for tenant B. So if blob storage B is only accepting traffic that's authenticated by its identity provider, and web app A can't get an access token from that identity provider, there's no way that web app A can talk to blob storage B. And so what we need here is a way of introducing an external workload to a tenant. And perhaps to help clarify what I mean by that, I'd say service A needs a way to authenticate to tenant B using an identity that tenant B will recognize. And we'll talk about a couple of ways to make that introduction, but note that these aren't the only ways. But regardless of the exact process followed in making a workload known to some other tenant, one point I want to impress upon you is that a core requirement of making such an introduction is that there must be some level of trust between the two organizations involved. And this is really highlighted by the fact that a human will almost certainly be involved in this introduction, as you'll see in the next 2 examples. The first of which is making an introduction by sharing credentials. And I know that sounds terrible, and it is true that if you can avoid doing this, then you absolutely should. But one really straightforward way to have a token issuer recognize an external workload is if we register that workload as an application in the same tenant as that token issuer. And when we register that app, it's going to have an application ID and an application password, also known as a client secret, associated with it. And those credentials could then be communicated out of band to someone in the external tenant who can configure that external workload to use those credentials. Now, I know that was a lot of words, and it's probably easier if we visualize it and talk through the flow. And the flow here is going to start on the right side of your screen with a human in tenant B. And that person knows that there is some external workload, web app A, that needs to authenticate to their tenant. So what that human could do is start by registering an application in their own tenant. And as mentioned, the output of this registration would be an application ID and a client secret. That's step 1. As the second step, human B would find some way to communicate this set of credentials to human A in tenant A. Perhaps that's a hand-delivered note, maybe it's snail mail, maybe it's sent over an email, a Teams message, or any other suspect way that humans like to communicate credentials. But once those credentials arrive in human A's hands, step number 3, human A will configure web app A to leverage those credentials. And once these setup steps are done, we're effectively at a place where we can make cross-tenant calls. Step number 4, web app A is going to call the token issuing service in tenant B and say, hey, I'm web app A. Here's some proof that I am who I say I am. Please give me an access token for blob storage B. Step number 5, the token issuing service is going to validate the caller's proof of identity and respond, hey, I know you web app A. Oh, and you're trying to talk to blob storage B? I know that guy too. Great guy. Sure. Here's your access token. And step number 6, after that exchange, web app A is going to have a proper access token, and it's going to be able to make authenticated calls to blob storage B. All right, great. We have a solution for making cross-tenant calls. Unfortunately, sharing credentials like this can be problematic. Not only do you have to communicate credentials out of band as part of this initial setup, you're going to have to do it repeatedly because at some point those credentials are going to expire. And at least in that case, you have an expiration date so you can plan for it. But in the worst case, there's always the risk that those credentials could get stolen or leaked. And then you're going to be scrambling reactively to mount a cross-organizational response to rotate your secret. Furthermore, it's likely that this process of generating a new secret, distributing it across tenant lines, and beginning to use it is going to be slow. There's almost certainly going to be humans involved in both organizations that need to manually take action. And maybe that's okay for the initial setup, but once these services are in production and taking traffic, the latency involved in a reactive secret rotation like that could easily lead to service interruption or downtime because the calling service won't be able to access its dependency, and maybe it's a critical one. Lastly, this approach just doesn't scale well. Imagine an ISV were to apply this pattern in integrating with hundreds of its customers. Having to perform these steps manually for each customer is going to be a management pain point. Now, that was a long list of problems, so I'm about to tell you that there's a better way to do this. And that's to leverage a multi-tenant application, which is as easy to do as configuring the application to be multi-tenant when we're registering that app in Azure AD. And the reason it's useful for us here is that a multi-tenant application has an application identity that we can make known in one or more external organizations. However, we can't just forcibly create our application in other people's tenants. We're still going to need this organization-to-organization trust here, because the way a multi-tenant app gets provisioned in an external tenant is for a human in that tenant to consent to the application being provisioned there. Let's take a look at a visual representation. So in this case of using a multi-tenant app to make an introduction, the first thing I want to call out is that in this approach, we're starting on the left with a human in tenant A this time. And human A knows that his organization has a web app, which will need to make calls out to services in one or more external organizations. So with this in mind, step number 1 here is that human A registers his application in Azure AD as a multi-tenant application. And again, the output of this registration process is going to be some application ID and maybe some client secret. And step number 2, human A is going to configure web app A to use the credentials associated with that app. Now here comes a really interesting step. Step number 3, which is where a human over in tenant B with sufficient privileges is going to take some action to provision the external application into their tenant. Now, that action could be running a PowerShell commandlet, or it could be opening up a web browser and performing a web-based consent flow. But the important point here is that human B is actively making a decision to trust this application that's been published by organization A. And perhaps some other time we can walk through more concretely what this consent process looks like. But after these first 3 setup steps are done, we're effectively at a place where we can make authenticated cross-tenant calls. And they're essentially going to go the same as we saw in our last example. But I want to emphasize a key difference in the next couple of steps that's really cool, which is that when web app A calls the token issuing service in tenant B to say, hey, I'm web app A, here's some proof that I am who I say I am, please give me an access token for blob storage B, I want you to note that web app A is still able to prove its identity to the token issuer in tenant B, even though those credentials associated with the app never cross tenant boundaries. And in fact, if human A were to update the application in Azure AD to have a new client secret, and then he updated his app to use it, that web app could still authenticate to tenant B's token issuer. And this magic is due to the fact that when the application got provisioned in tenant B, under the covers, it's still ultimately linked back to that app registration in tenant A. And the great thing about this is when credentials need to be rotated, whether it's due to them expiring or due to a security event, only one organization has to respond, and that's organization A. So the key takeaway here is because credentials don't need to be communicated out of band ever, leveraging a multi-tenant application is probably the better approach, introducing a workload to an external tenant. I want to close out with a quick mention of authorization. Because so far, the unique problem we've been talking about how to solve is really one of cross-tenant authentication, making an identity provider recognize some external identity so that that external identity can get access tokens. But to close the loop here, and to get back to our initial scenario, where we've got some web API that we want to protect, and I talked about how we need an identity context to inform our response. Well, that identity context is going to allow us to enforce our authorization policy. In many cases, it's typically not going to be enough to just know who the caller is. You also need to know what the caller is allowed to do. And this is generally achieved by granting the caller permissions, typically in the form of roles. And you're probably familiar with this, but if the service you're trying to call is an Azure service, you could go to the Azure portal and assign that identity an appropriate Azure RBAC role, add an appropriate level of scope to grant it access. But Azure RBAC isn't the only authorization system you may encounter. For instance, when we take our web API and register it in Azure AD, we can also define application roles there, which can be assigned to identities. These roles would be included in the access tokens that our service receives, and that information would allow us to enforce our authorization policy. Now, I kind of left authorization here as a footnote at the end of this talk, but that's because there's not really a whole lot new here in the cross-tenant case. This aspect is the same as it would be for communication within a single tenant. The only slight difference to note is that assigning roles to an external identity is only doable after you've introduced that external identity to your identity provider. And with that, thank you for your attention. I really hope you were able to learn something from this session. And if you have any feedback or corrections, please reach out, as I'd be very happy to hear it. Until next time.